Good afternoon. This is the Accellera Town Hall discussion where our focus today is going to be on the topic of functional safety standard. Where is it? Why would you want to adopt it? And we are missing one of our speakers. It's double duty in this compressed DAC scheduling. While lunch is supposed to begin around noon, that is not the case for all of the activities happening right now. And we have Serge Leef, who will be joining us, the DARPA representative. After his presentation should be over 12:15, 12:30, and he asked me to draw things out a bit, and we suggested maybe he shrink some of his slides. So hopefully he'll have a few more things to say that a little bit shrunk down. But I'd like to thank the chair of the Accellera Functional Safety Working Group, Alessandra Nardi, who will be introducing all the panelists, and for putting this together and bringing us together as well to have an open conversation on functional safety. In design automation, we're trying to get things that are not just right in the function of the features that are being put into these systems, but to make sure that they are there with the same fidelity of safety that end users are going to expect. And those range from, well, maybe we know about autonomous vehicles and items like that, but certainly there are a lot of other areas in aerospace, defense, industrial devices that are extremely important to have safety built into them. All the comments that the speakers are going to make today are their own opinions, so we do invite you to test some of their statements and their positions. We have a mic up front for you to come and ask questions. We won't be passing the mic around for safety protocol, obviously. And we'd like to thank the Accellera global sponsors who sponsor these live and online events for us. The membership of Accellera also welcomes all of us here. This is maybe this year, our second in-person event. We did have a design verification conference in China, which was held live and in person. Just the fact you had to be a Chinese national to show up, as travel is obviously impeded at the moment. We also have other standards that are in practice and in discussion at the conference. This slide was rotating, and we certainly hope you can avail yourselves of attending some of those as well. And more recently in the news, if you go online to accellera.org, you'll be able to hear and see a bit more about what we are doing in the area of some of the standards that are coming out. I believe the white paper and the activity from the Accellera Functional Safety Working Group will also be of interest to you. And as always, if this topic or other topics interest you and your company is not a participant in Accellera, we certainly welcome you to join us and participate. But without further ado, what I'd like to do is turn it over to Alessandra Nardi, who will introduce the speakers and the topic that we have today. Alessandra?
Okay, so I'll start with giving an introduction about the group, but first, we discussed about whether to introduce each of the speakers separately, and then we figured we would be here for 10 minutes or so. So I don't have the exact count, but I think we're going close to 100, a century of experience of functional safety on the panel, combined, of course. Alex from AMD, Ghani from ARM, and Bharat from TI, and then we'll have Serge when he can join us. You have the name in the front. You'll hear as they speak how much experience they have. They've seen very different aspects. They are not just being from the same company the whole time, except I think Bharat is the most, the highest tenure there. But anyway, point being, we have a lot of expertise, so we'll cover a few topics. Feel free to ask, and I'll improvise here. Feel free to ask anything on functional safety because I'm sure they can actually cover it. And then Serge will give us a little bit of an angle on the security as well and the connections to that, okay? So we'll start by giving you an introduction to the Functional Safety Working Group in Accellera. What they're going to cover goes beyond the standardization part itself. It's more about, what what is functional safety, why are we talking so much about it, what is difficult, what is different about it, but also what is the future, because there has been a lot of evolution in the last 4 or 5 years. I've seen it myself. I started on safety for 6 years now, 5, 6 years. But there is a lot of activity. It's moving a lot into the automation part, but this has been around for a long time. And there will be more and more changes. It's a green field in some sense of things that we can do new, okay? And so even though I'm going to give an introduction on the functional safety working group and the standardization effort we started, the questions and the topics are going to be, in general about functional safety. Okay. So I'm going to give you a very short history and statistics of the Functional Safety Working Group. We formed it 2 years ago as a proposed working group. That's the regular way Accellera, starts the working group. The goal of the proposed working group is to figure out the industry needs and support. So, what do we need and why do we need it? Do we have enough support from the industry? And that's the process. I was wondering about it, and then I figured it's extremely helpful because it helps you to really write down what are the problems, like what is the problem we want to solve. And even now in the group, and you'll see that the approach we have taken is a layered approach of starting with one topic and then adding on top. For the additional topic that we find in our way, we always start with this approach, what and why. And we first figure out whether we have a problem to solve or not, okay? So we officially formed it in 2019. We had the first face-to-face kickoff literally exactly 2 years ago, so December 6th in Munich. That feels like ages ago. And so after that, we did a few months of writing down, as I said, what we think were the pain point, the things the industry needed. And that was open to everybody, to the community, not just Accellera members. So we had 30+ companies in that initial phase. And in February 2020, it was becoming officially a working group. Okay, and then we started the real work. This is actually the first time we meet again in person, so we're very happy of having this chance here. We have done a lot of virtual faces-to-faces. We regularly meet. We published the first white paper in Q2 2021. And then now we're working on the data model definition, okay? And so we are hoping to have the first draft by Q1, and then on the data model, building a language by the second half, okay? Now, again, in the working group, the work is actually focusing on how, so the execution. You can see the leadership at the bottom left corner. We still have a very significant representation. Now, the stakeholders for what we're doing, we believe, are IP, EDA, system, silicon. We have a significant representation for IPs and silicons and EDA, and we hope to extend that also to the system level. Okay, so the mission of the group, what you see on the left are the challenges. You'll find all of this on the white paper. I'm just trying to summarize it very quickly today. So these are the challenges we formalized and we put into the white paper. Number one challenge that the group felt is exchange of same data across different automation tools. That came as, they're not in order of priority, but that was one of the buckets of the problems. Connection between functional safety data and design information. Sharing of different functional safety data across operations and work products in the same layer, which means the same, either the same company or the same provider, the same layer of the supply chain. And then exchange of functional safety data between suppliers and integrators. By coincidence, this is in red, but it actually came out as the hottest topic in the group. So we didn't do it on purpose, but it's very appropriate. And the last one is traceability, which is all across these challenges, actually, right? So these are the challenges we identified first. As I said, we are finding out more, but these are the first few buckets. What we feel the standard is going to address is improving these problems and improving interoperability, traceability, and automation. So that's the mission of the group. So this is a little bit of details. You can find a lot on the white paper, but I wanted to show the kind of work we are doing. Even though a lot of people worked on functional safety, there's a lot of expertise. When we started talking to each other, we realized that there were a lot of nuances. So the first was for us to start understanding each other, formalizing the process. But the goal is to define what you see, the central box, the functional safety data, everything we need to generate all the other boxes. So all those double arrows are potential for standardizations. The slide, the way it's presented, a lot of people ask, does it mean I do an FMEDA only for the IPs? No. But there are so many dimensions to this problem, it's difficult to do unless you do a 3D. The goal here to explain that this functional safety data is shared across IP, component, module, and system. EDA is kind of going across, and then we have these terms interlayer, which is within the same layer, within the provider of a module, within the provider of a system, right? And the interlayer across. So the box, we should have made it probably bigger. The functional safety data is really trying to connect all of this and allowing you to generate, to support your work products and your best practices. So where do we sit with respect to the standardization landscape? Because there are a lot of functional safety standards already, which are, adopted and quite well known. I'm not going to talk about the bubbles you see on the left, because I think the presenters also have these bubbles. So there is this whole landscape of existing, and the most renowned one being IEC 61508, and then the automotive one. So these define best practices and guidelines. So the summary of the challenges we saw is the implementation of these best practices and guidelines. Okay, so how do I actually implement? Like, I have to do a bunch of things. How do I make my life easier? And that's the goal for us. That's the goal for the Accellera Functional Safety Working Group, to define a data model, a format that enables, more efficiently and with higher confidence, the implementation of these best practices. So that's how we fit. Once the standard is being published and then adopted widely, and so it's mature, the collaboration between Accellera and IEEE, there is a long-standing collaboration. If you see on the website, you'll see a lot of the standards developed in Accellera, published in Accellera, and then later on passed to IEEE for publishing. We plan to follow the same model. Okay, so first we mature the standard, we publish it, the industry gives it positive feedback, and then we follow that path. So that's kind of the picture we have here. I'm about to wrap this up. So this is where you can find the white paper. It's again, on the website. And the last is, please join us. You can find all of the information there. All of this that we are doing is work in progress. So there is a lot to be done. This is the basic of what we're doing in the standardization working group. Alex is going to talk more about the cost of safety. You'll see how passionate he is about that. After that, well, how passionate he is about everything, actually. So it's a compliment. So Ghani, I think, is going to cover, why is safety different? What do we do about it in the processes that we already have established? And then Bharat is going to talk about also the other industries, because most of the focus for the group, but also in the news, it's all about ISO, or a lot about ISO, or maybe that's what I notice. And so Bharat is also going to create that connection, and then when Serge joins us, he'll talk about the connections to security. Okay?
Okay. So just, so Alex asked me to discuss a little bit on the functional safety cost. We discussed about that, and yes, I think in my career is a lot of people asking about how much does it cost to actually go into functional safety. What is the cost that the device is going to have? What is the cost of development? And so that's the idea that I was trying to do here with some of the slides. So here, the slide that I've put together here is just a recap, and making sure that people understand when we talk about systematic and when we talk about random, what we are talking about. So systematic is release process, making sure that we have the paperwork done, that we do the development correctly. That's the basic, I would say, from an engineering standpoint, but I think the ISO made it clear that it was not an option. On the random side, it's all about what do you do to cover your diagnostic and how do you catch the failures. And so there is these 2 points, and I'm going to go back and forth between these. So here what I'm trying to show here is the cost of development of a typical project in gray. And what you'll see is that I've drawn the red shape, which is actually the cost of development when you apply functional safety. And what you see is that you have this shift left that is happening where you are going to spend a little bit more in development upfront because, well, we have to write spec, we have to make the review, we have to do all these type of things. But interestingly speaking is that by doing that, you are reducing your failure rate at the back of the development, which happened that it's when the verification and validation arrive, you have already solved some of the problem that you will not see if you've not done accurately your definition and functionality. And I think in 10 color is actually a runaway project that you typically have because people have cut corner at the beginning. I'm pretty sure a lot of people here in the assembly went through some company, and some people, decide to write RTL before they write spec, decide to do some testing before they actually understand what to be tested. And what happens is that by the end of the project, you are not converging in your verification, and your bug rate is still improving and is still growing. And unfortunately, the time to market is delayed. And so for me, this is the thing. Some people think that cutting corner at the beginning buys in time and it's cheaper. The reality is that, and I have been in enough company, whether it's TI, whether it's Freescale or NXP and things like that, that when you do a device with functional safety, it actually doesn't cost more than the other. It actually costs less because you don't have to repay for mask. You don't have a verification that run away. So that was the point of that slide. So in fact, what we can say is that on the systematic side, applying functional safety is not a deep, well where you are just throwing away money. It's actually saving time and money overall. So when you look at the big picture, you can see that there is a saving there. If we go to the next slide, so now here it's a little bit more complex because here what I'm trying to represent is the cost of development for the diagnostic. So some people have some difficulty to understand that, but pretty much what we do is that in functional safety, whether you do hardware or if you do it in software, you have to develop it. The hardware is going to cost you in the time of production because it's always there. And from a software perspective, it's a cost of development at the beginning. Now, the thing is that the more hardware you have, the less software you have, and then where is the right balance of hardware and software? And so that is always the main issue during development is where do you stop adding hardware and where do you switch to software? And so this, for me, it's where when you have a good functional safety architect to understand what are the things that you need to do to get to your quality metrics, whether it's 90% coverage, whether it's a 60% LFM, etc. This is where you need to understand. You need to have a good functional safety architect. It's always a trade-off. Everything is a trade-off in functional safety, so there is no silver bullet. I've been asked a gazillion times by vendors, by people say, oh, what is the best functional safety? Well, best functional safety is the cheapest one, right? That does the thing. That is the thing, it's a balance, and it's experience here pretty much that will get you to the right coverage and things like that. But I wanted to make that point, and we can discuss about this point. Obviously, you will have to have some people on the functional safety side, like functional safety architect and functional safety managers. Of course, they are not free, but sometimes a good functional safety team avoid the good court appear. So that the benefit of functional safety when you sell to the automotive market is that at the end of the day, you're not going into court if you're doing your job right.
Thank you, Alex. A lot of times I've heard that, functional safety cannot be an afterthought, and I think it's very much aligned to that. Maybe we can pick it up afterwards again. Ghani, please.
Okay, this is the question I'm going to answer today, is does functional safety add complexity to development of a product? And I'm continuing what Alex started. Alex took it more from a cost. I'm taking it from a complexity perspective. And it fit the work I have been doing. I started working on functional safety several years ago when I was working for Intel. And I was one of the few people who started looking into the subject of functional safety. So when I showed some interest, they gave me the job to go and convince all the design managers that functional safety is something easy to do. So my role is to go and talk to every design manager and say, by the way, this is something very simple, anybody can do. He said, if it's simple, why don't you do it yourself? And when I start to answer this question, is safety more complex? Does it bring more complexity to the design, to the development of the product? And I say, yeah, I mean, of course, and anything you add, any feature you add to the design, it's going to bring complexity, correct? There's always, we see this in our daily life, whether it's a performance, feature, interface. Anytime you add a new feature into the design, you're bringing complexity. Now the question is safety bringing more complexity to the design? I started thinking about this over the years. What did I learn? What's the things that I learned the most? And I would say it's not like a very easy to answer this question. You can't just say yes or no. You have to say yes, but, or you can say no, but, correct? So this is exactly how I'm going to answer this question today is, what are the things that make it complex, or what are the things that does not make it complex? So you say, like any new feature you add, there's always interdependencies, correct? For example, say security. If you guys have designed for security, you can have the same problem, correct? I have a security problem and I have a feature. What's the complexity of the interaction between these features? Performance and other features, there's always the interaction, and the interaction actually is the complexity. Because now you're not only testing the feature standalone, you're testing the feature with other things together, and you want to make sure that there's no holes or side channels or interdependencies that you cannot test for some reason because of the complexity. There's also another aspect of it, there will be conflicts. Like, for example, again, I'm going to pick on security and safety. There's always conflicts. You think that you are designing for performance, for example, and then you find out you are affecting security, for example. By adding more performance feature in your design, those same features that will increase your performance can cause security holes in your design. Similar to safety and security, for example. You can optimize for safety, but at the same time you are opening holes for security. Or you can optimize for security and you are opening holes for safety. And safety and security are going to remain forever, correct? There's no way you can design for safety without having security in the background. So what do you do with those? And you have to make a judgment at the beginning. What is my priority? Is it the safety or the security? Those decisions, the more you resolve them early on, the better your chances of not creating problems later on down the development. So also the answer depends on the current processes that you have currently. For example, a company, a startup who never designed who doesn't have a process. When I say process, means a design process, a life cycle development process. Like, what am I going to do in phase 1 and phase 2 and phase 3? What are the design processes that I have to follow? If you don't have those in place, of course you're going to have a problem, whether it's security or safety or anything else. If you have the design processes, the chances you're going to have a problem is much less. The chances that you're going to have a complexity is going to be much less. If you don't have any of these processes in place, you're going to stumble, not only on safety, but on the other stuff. So to reduce the cost, you should have, before you start thinking about safety, start thinking about how am I going to design this product? What is the process I'm going to follow? Whether it's a front-end design or a back-end design, you have to have those in place and reviewed, sanitized, run some test cases on them that they would work before you go say, okay, now I'm going to add security or I'm going to add safety. It also depends on, as Alex was saying, when you apply safety. Many people think that safety is an afterthought. Once I finish and test it and then show it to my customer, demonstrate my functional features to a customer, then I'm going to give it to another team or the same team, say, by the way, start patching it and adding, sprinkle some safety mechanisms or error detection mechanism everywhere in the design. That doesn't work. That doesn't work at all. In fact, you're going to create some complexity. Now you have a design that is complete and you're trying to change the design, morph the design to something with safety. It doesn't work that way. It's very complex. And many people tried it and they failed. Instead of taking you, for example, 2 months to finish the safetiness of the design, you're going to spend the whole year trying to fix your design or patch your design. And even if you manage to get it there, you're going to find many holes, or your customer will find many holes in your design. So you better have this complexity solved from day one. Think safety from day one. You don't push it till the end. And you have to sprinkle it in your milestones. Like, in the first phase, this is exactly what I'm going to do. In the second phase, this is what exactly I'm going to do. You have to have a process for safety similar to other things you have in your design. It also depends on the tools. So one of the things that if I look backward now, we used to do most of the tools used for safety, like Alessandra mentioned about the FMEDA tools and so on. We used to do manual work. We start with a spreadsheet, and I think most of you are familiar with that. We start with a spreadsheet, and then we realize that this spreadsheet has a lot of holes and problems. So we start automating the spreadsheet, and as you're doing automation, you're creating problems. And then now, instead of solving your initial problem, you're solving the spreadsheet problem. So again, you have to use the proper tools to do your design. Whether it's an analysis tool or a verification tool for safety, you have to find what is the best in the market today to solve your problems. Don't try to solve everything yourself. I mean, there are companies, this is their job, is to create the best tools, and you doing the tool yourself is you adding another level of complexity. So I took the approach now, and I said, okay, let me dissect it. The example I'm showing here is specific to hardware development, especially a soft IP, because the company I work in, we only develop soft IP. Soft IP means that we develop the RTL, and we don't deliver to our customers or our partners, we don't deliver silicon or a netlist, we deliver to them an RTL files, and then we tell them this is our product, and this is our other evidences that we have completed our safety work for our product. So this is exactly what you see here, coming from the standard. Like if you're developing hardware, a piece of hardware, first of all, you have to start with a concept. What is the functions of the thing you're trying to build, correct? You can't just say, I'm going to build a hardware. No, you have to define exactly what is the requirement of this hardware. If I'm using your hardware, what is the advantage of your hardware that you're giving me that I can use your hardware? So this is what we call a technical safety concept, driving it. And then this other requirement, I'm going to skip 5.5. Again, this is coming from the standard. Basic now, what 5.5 means, I have to build a hardware. I need to build a plan how to build the hardware. So this is what initiation of the product development. I mean, it's more complex than that, but think about it for the simplicity here, is that I'm going to build a plan on how to build this hardware. Now, 5.6 is where you have, as I say, you start with the technical safety concept and say, okay, now I need to build some hardware, correct? So I need to derive from this technical safety concept the hardware features that I'm going to build, correct? So now you're going down. Somebody tell you, you have to build some function, and now you're saying, okay, what is the hardware that I need to do to build this function? So this is what 5.6 is from this function definition, drive what the hardware that you need to build. Now, from those requirements of what you're going to build, you derive your hardware design, correct? That's all of us do to every day, correct? We derive our hardware design, and hardware design means that the design, this is not the implementation, this is the design. We're still talking about the design here. 5.8 and 5.9 are specific to safety development. So you have to analyze your design to make sure that it doesn't have any systematic problem and it doesn't have any random problem. Alex, I think, went over these two topics. I don't know how many of you have been in functional safety or designed for functional safety. If you're developing for functional safety, many people think that we're only focusing on if something happened, a fault happened in the design, what should I do? How do I detect this fault? Actually, this is only part of it. So there's two parts. One is making sure that the design does not have any systematic problem, like a bug, for example. And the second one is the random. Random means that if a random fault happened in the design, how they detect it. Only the random aspect is specific for safety. But the first one about systematic, this is what we do every day in our designs, regardless whether it's safety or not. And then, you do the integration in 5.10. You take all these components together after you tested them, and you do an integration testing on them. And then the 4.8, the last point here, is the integration and testing of these pieces of hardware you build at the system level. Now, if I looked at all of these, correct? Again, I'm not looking at safety now. For those of you who never designed for safety, but designed for something else, you look at everything I mentioned, you say, well, I do everything, all of these I do them with the exception of 5.8 and 5.9, I do them in my daily work. I do design, I do a requirement, I do a hardware requirement, hardware design, verification. I do all of this. What do you think means? Do you tell me that safety is the same? If I'm designing for safety is the same as designing for non-safety? I would say yes. So now I'm thinking, is there any complexity in this? No, probably not. Again, going back to what I said earlier, if you follow the proper processes for designing, the likelihood of having problem is going to be much less. If you didn't follow any processes, or you're designing your safety development at the end of the project or in the middle of the project, most likely your complexity is going to be way high. So remember this picture, and now look. Here what I'm saying, if I look at the product requirement, which is the first step you do, somebody tell you have to build a requirement because this is what the customer wants, okay, we do that. So there's no additional complexity, just adding yet another feature for safety. The technical safety concept is similar to what you guys do today. Customer give you a feature, you derive the functions that you want to build for the customer. So this is something you already have done in previous projects. Now when you look at 5.6, specification of hardware safety requirement, this is specific to safety requirement. So this is not something I have done before. So this is one thing that is extra you didn't do before if you have not designed for safety. So you have to worry about it. It does complicate things, but it's not terrible. It just, I'm adding another feature yet another feature that I have to worry about. And then you go to the hardware design, it's the same thing we have done. You go to the evaluation of the hardware metrics. This is something we have not done. We still have to do that. This is the new work that I have not done before. So basically I promised that my design will detect both systematic and random failures, and now I have to prove it. Not only to myself, I have to prove it to my customer. This is not something we have done in the past. In the past, what we give our customer a product, we give them some tests. They say, by the way, this is out-of-the-box test. You run the design we gave you, and if you find a problem, come back to us. Most likely, they're not going to find a problem because we have done enough testing in-house that we make sure that the customer will not find these problems. Now it's different. Now because it's safetiness, there's safety out of it. We're worried about safetiness of people, so we have to show evidence that we have done our work. So it's not enough to tell the customer, my product is good. You have to show the evidence to your customer that your product is good. So this is something you have not done, and most likely it will take you some time. Not like a week or two. It might take you months to produce these evidences so that your customer believe that what you give them is safe. And by the way, this is not only satisfying the customer, it's satisfying the standard. The standard require you that you show evidence that anything you have done to prove the safetiness of your design, you have recorded this evidence. And at any point in time, during the life cycle of the product, you have to reproduce this evidence when you've been asked. So this is another level of complexity, if you think about that, we've never done in the past. The hardware integration and the integration testing, I don't think it's more complex because this is what we do in our non-safety related products. So those things, typically, we know how to do them. So if you look at the map here, you see that there's 3 items that popped that we never did before when we didn't have safety products. And one of them, as I say, is the specification of the safety requirements. How do I know what safety requirements I need? We never did it. I mean, if I give you a piece of design and say, by the way, tell me what I need to do to make sure that if a random fault happens, that fault will be detected. I mean, it's not obvious to people who never designed for safety. This is something you have to worry about. You have to know how to analyze your design so that you can find the holes in the design and how you protect against these holes. Similarly, on how you evaluate the features in your design that will detect the failures. There are metrics that we use in safety, and regardless of what safety standard you are using, there are certain metrics that you have to abide by those metrics requirement. And this is not something intuitive for every one of us. It's the skills that you have to build from one product to another to know exactly how to evaluate those metrics. If I look at the table on the right, again, this is Ghani giving his own interpretation. This, going back to the disclaimer, this is not ARM disclaimer. This is Ghani after so many years of experience. Like, where do I see this impact on complexity? So if I look at the ones that pretty much we do on a day-to-day design, whether it's safety or not, I would consider them low or medium complexity. When I say low or medium, it's a matter of weeks, no more than that, to fix this problem. But when it goes to the one that I'm showing with the red crosses here, these are the one can be very high, depends again when you start doing this type of work, medium to high complexity. Now, I talk so far only about the design itself, design and the verification of the design. There are other things in the standards usually that you have to do that you did not do before if it's not a safety product. And I listed those here for the automotive standard, the ISO 26262. But it doesn't mean that only automotive have those processes that you have to fulfill and show evidence that you have completedness. Other safety standards have something similar. So I'm going to go through them very quickly here. There's the management of the safety requirements, correct? So many people are like, what does it mean, management? If you think of when you have requirements in your design, like say I'm going to build this interface, I'm going to add these features, and I'm going to have these registers. Those are other things that you have to worry about, correct? The management of the safety requirement means that, do I have a place where I review my requirements, categorize them? If they change, I know exactly what else I need to change if the requirement changes. This is what it meant by management of safety requirement. And I'm going to be honest with you guys, in the several companies that I worked in the past, we didn't care about this. I mean, the minute the product is done, we throw everything in destroy bin and then we move on to the second project. This is not the same here. So this is another level of complexity that we never picked up till we start working with safety. Configuration management, change management, verification, documentation, all of these I just mentioned, you guys pretty much do on a daily basis. Now, confidence, and then these other two, which is the confidence in software tools and safety analysis and so on. Those are another level of complexity. Again, it's not like a matter of a day or two. Sometimes it takes you months to make sure that any tool you have used on your products, have the capability to be used in a safety environment. You can't just pick a tool off the market and say, okay, I'm going to use this tool. You have to show that this evidence can be used, and there's requirements, there's certain requirements how you can use a tool or not. And those something you have to abide for and spend some time making sure that the tool can be used. And I mentioned that the safety analysis early. The safety analysis we never did before, correct, for a typical design. But for safety design, you have to have some work done here. And again, here I listed some impact based on what I see. And if you look at, most of them are low, except when you talk about the safety requirements, the confidence in the software tools, and the safety analysis. Those I consider them to be medium to a high of complexity.
I think you can sense these people have been pioneers in something that is now becoming mainstream, but pushing for the right things to do. I think you can sense it in how they're talking. Okay, so next one is Bharat.
Okay, sure. Thank you. Hopefully you guys can hear me. The mic is working. That's fine. I got to give it to Ghani here to try to make you guys safety experts in 20 minutes. Definitely a valiant attempt. So let me see if I can try to blow your mind some more and give you a flavor for the various different types of industries that actually have safety standards that people have thought about. So what is a safety standard, first of all, right? So safety standard is really a collection of what is reflected as the state-of-the-art that has been put together by subject matter experts, right? So these are not laws that have been enacted by civic governments, so there is no compulsion to follow them. But if ever there is a safety incident, the question that always comes up is, did you do your part to follow the state of the art? And that's the question that comes up in a court of law all the time. So in that regard, and in that context, by the way, there's going to be a pop quiz before you leave on which standard corresponds to which industry. No, just kidding. I don't keep that information memorized myself, so that's why I have the slide in front of me so I can talk to you about it. So in that context is why all these different industries pulled on their respective subject matter experts who had expertise in those industries and pulled together safety standards. So if it were a popularity contest, the ISO 26262 standard would win it, because that is hopefully a standard that most of you in this room have heard about. So that's off at the 1 o'clock of the clock looking figure. Then moving in a counterclockwise manner, we have all other modes of transportation that is covered, including the Blue Origin flight that was going to leave later today, I think. The ISO 12207 is adaptation for software in space-related applications. There's the DO-178C and the 254, which deals with aviation. And then we have the EN-5021X, which deals with railway applications. From a medical device perspective, the medical industry chose to break out medical device software in IEC 62304 and medical equipment according to IEC 60601, respectively. Then you have furnaces, nuclear power plants, and I'm not going to go through all of these in great detail. Just to give you the irony of things, over by the 3 o'clock, 4 o'clock hour, where you see the IEC 62061 and the ISO 13849, they're actually two standards from two competing standards bodies, the IEC and ISO respectively, that talk about the same thing. They talk about the safety of machinery. And believe it or not, some years ago, there was an attempt to try to combine or collapse those two standards into a single standard, but the IEC and ISO failed at that attempt. Last but not least, we have electrical drives and even standards that cover forklifts and farm equipment that most of us are familiar with in day-to-day lives. So with all of these standards out there, why do we need so many standards? And let's just take a look at a couple of standards. This is my super high level, 30,000 foot level view of comparing and contrasting the ISO 26262 standard to the original functional safety norm, which is the IEC 61508 standard that covers safety of programmable electronic safety-related systems. So typically what ends up happening is it ends up becoming use case driven. So just take, for example, a typical car. You turn it on, there's a key on-off cycle or an ignition cycle associated with the usage of electronic components in the car. You drive for 45 minutes to an hour in the morning from home to work, pre-COVID times, of course. And then you drive back home. Maybe there's a couple more key on-off cycles over the weekends. In contrast to that, when you look at industrial systems, factory automation, robotics, those types of things, there are use cases like high demand mode or continuous demand mode, which really don't have a parallel in automotive applications, at least till you get to robo-taxis that are driving themselves on the road all the time, and maybe that's 10, 15 years away. So these are some of the higher level differences between the standards. There's slight differences in how you do dependent failure analysis, coexistence analysis to guarantee freedom from interference. The 61508 standard talks about a beta IC, whereas in ISO 26262, it's a more of a qualitative handling of how dependent failure analysis and coexistence analysis is done. And there's a few other nuances. But this is just to give you guys a feel for all the different industries and all the different applications and all the different standards that are out there. But at the end of the day, if you have to remember one standard that is the most important, that's the middle of the clock on the right-hand side picture. That's the normative standard, IEC 61508. And I just share with you that I'm part of the U.S. National Committee working on the 3rd edition maintenance team of the IEC 61508, and we're looking to release the 3rd edition sometime in 2022. With that, I'm going to hand it over to Serge.
Thank you, Bharat.
Thank you. My name is Serge Leef. I work at DARPA. I'm a program manager focusing on next generation EDA, secure silicon, domestic microelectronics, and a number of other topics. I'm actually more focused on security than safety, and I'll characterize myself as a functional safety skeptic. And I thought this panel could use some controversy, so I'll inject. Opinions expressed here are my personal opinions, not those of the US government, the Pentagon, or DARPA. Basically, what I'm doing at DARPA is I'm trying to secure chips, secure them from multiple attack vectors, including a supply chain attack vector, which directly relates to safety of the derivative systems. And in a supply chain attack vector is where the chips are recycled, remarked, overproduced, and essentially are not as reliable as genuine articles. But to put it into proper context, the work that we're doing is to defend future microelectronics on these 4 attack surfaces. The first attack surface is side channel. This is where an attacker can listen to emissions, whether they're power or electromagnetic or something else, and infer secrets from listening to those emissions. And we are basically assuming that all the outer defenses have failed and no shielding works and the adversary can listen to them. And the question then is there any way to prevent them from getting any useful insights? The second thing that we're working on is reverse engineering resistance. This is denying an adversary ability to look at the design and infer what it is supposed to be doing. And the purpose of this typically is to reverse engineer algorithms. It is not to copy the chip or send it to gray markets. And here we're making a conservative assumption that the attackers have already gained access to design files. How they did it is irrelevant. They have netlists and even RTL. And then the one that's related to this topic is the supply chain. This is where people clone, counterfeit, recycle, or remark chips, and they're subsequently sold as genuine articles. And of course, silicon transistors wear out over time, so the reliability of remarked recycled parts is dramatically lower, which should have linkage to poor safety. And then lastly, the thing that we worry about is hardware trojans, which is adversaries are able to inject malicious circuits. And here we have to worry about the Trojan triggers and payloads that cause things to happen. And actually, a lot of design errors are excellent entry points for those types of compromises. So the way that we are addressing this problem is by creating something called security engine that lives inside the chips. And we're doing this by working with the likes of Synopsys and ARM to incorporate creation of this right into the fabric of what comes out of synthesis. And the security engine has multiple responsibilities to protect the attack surfaces I just mentioned, but it also can be sized up or sized down depending on the intensity of protection and also depending on which attack surface you want to defend. So you can trade off the size and capability of the security engine against other economic factors in the chip. And so all of this stuff has an off-chip companions infrastructure. So we call it asset management infrastructure. So somewhere on the cloud, there's a repository. In our case, we're building it out with blockchains and distributed ledgers, where every chip ever manufactured, every die has unique identity, can be enrolled at manufacturing time, authenticated at any given time, and tracked anywhere in the supply chain during manufacturing, during the assembly and test, during device or system integration, even during the field use. So that's basically the connection I am mentally making to safety here. But before I'm done, I will tell you why I am a skeptic about functional safety. So back before I joined the government, I was a VP at Mentor, and I had a business unit in my division that was responsible for automotive electronics and in-vehicle software stack. And somewhere around, I don't know, 8 or 9 years ago, maybe a little longer, my customers, particularly the European OEMs, started to make demands of 26262 compliance. And granted, this was in early days of 26262, but when we started asking them what exactly are they looking for, nobody could clearly articulate to us what a compliance to that standard actually meant. And what I have learned from all this is that there was only two answers to this. We are not doing anything about it, or we're doing something about it. And as long as we said we are taking some steps to be compliant with 26262, they didn't ask any further questions. So it led me to believe that this is some kind of an administrative checkbox as opposed to real search for safety. And so I hope the situation has changed since my experience and people are really focusing on safety, but back in the day, it didn't seem that way. And then my other observation is, in the government, I encounter this whole amorphous concept that people talk about all the time. They call it quantifiable assurance, which I guess is sort of linked to your concept of functional safety. And what they mean by this is they want to be able to somehow establish assurance that, and quantify it, that the defense systems are doing what they are intended to do. So in this case, it isn't to protect lives necessarily, because some of the applications may be intentionally life endangering. Okay, so but the point though is when they start talking about this, I start thinking about digital simulation, which is where I spent most of my life, and arguably lots of money went into developing technologies in this area, and literally everybody who is designing digital electronics is using simulation products. What's the level of assurance we can tell the customers they are actually getting? Even with the most sophisticated test bench strategies, I would assert that they cover 3 to 5% of the state space, if they're lucky. So if you're starting to talk about systems like an S-Class Mercedes, which has 200 onboard computers, each one having a gig of embedded software, how much can we really test? I mean, I would say large majority of the situations that are interesting and relevant to safety are unreachable in simulation. In fact, they're inconceivable by humans because we can't anticipate multiple failure scenarios. So those are my two concerns about functional safety, right? So I have a program at DARPA that I'm putting together right now that has to do with distributed system simulation. And the questions that I'm being asked are, can you prevent a failure like Boeing 737 MAX, right? There was a sequence of failures in those planes crashing, both in hardware and software and human operator. What is the technology that gets us to hit corner cases like that? And so this is going to take some state-of-the-art advances in simulation, in test, in fault injection, and that'll get us maybe to 5% exploration of the state space, which still leaves 95% of all possible things that could happen untouched. So with that pessimistic note, I'm going to conclude. Actually, it's not pessimistic. I'm just hoping to get the other panelists excited. So I will conclude with that, and I just say, so we're taking a very pragmatic, security-centric view on this. But I do work for people who care about the notion of quantifiable assurance, which may be a private label version of functional safety. Sure. And so I'm, like you, I'm looking for insights as to what can be done there. And not administratively, but what are the technical strategies here that could actually lead to functional safety? Thank you.
Thank you, Serge. Any question from the audience? Otherwise, I have like 1,000 that came up to my mind as they were talking. Anybody that has any burning question?
Is the mic on? Yep. Can you hear me?
Yep, we can.
Yes.
Okay. Ghani scared me. Bharat made all the other standards even worse. Alex assured me, though, we keep the lawyers at bay. And Serge tells us functional safety without other security still has a system which is probably unsafe. So to you, Alessandra, what are you doing to address these things, solve these things? Are you going from the 3% to the 4 to the 5? Mm-hmm. In Serge's case, or is there something contemplated to go even further and address more of this as well?
I actually have a more optimistic view.
Okay.
But I'll share my viewpoint, but then I'd like to have, what their feedback is. To Serge's point, again, I came into this like 5-6 years ago. I could see some of that where I was more of a checkbox, but what I've seen, and I think the story that old Bharat, Ghani, and Alex shared are consistent with that, is that there is much more of a push for real safety rather than the checkbox. And that's what I meant when I said, most of this is becoming mainstream. It's not just, limited set of applications. It's now becoming so widespread that a lot of people start understanding it. A lot of people start seeing the value and the requirements. So to my personal view, I think we are actually I'll summarize it. It's one more objective in the design. So we are all aware about PPA, right? At some point there was no low power, now there is low power. There was no safety, now there is safety. It will become, that's my take, it will become mainstream, where people see the value, where people, it's a requirement they'll just start taking into account. And I think we are in that direction. I don't know, guys, what do you think? Because, I think you had to push a lot at the beginning of your, at some point in your career, you have to push a lot to get consensus on safety. But I think it's becoming more and more mainstream. What do you think?
Well, I mean, to reply to Serge, yes, when I started, like, what?
Can you hear, Alex?
Yeah.
So
when we started, like, doing functional safety, I think, on 2002, 2003, when you ask the vendors or the mentors, there was nothing. Was clearly nothing. We had to do everything pretty much by hand, I would say. We had to fight, we had to request, well, if you don't do functional safety, we'll find somebody else. So yes, when somebody say, yes, you are going to take care of it, well, finally somebody took care of it. So we move on to the next question. Are you cheap? And so that was probably the other question. But I think at the beginning, the thing is that there was nothing. Carmaker basically fell down on the semis very quickly, saying it's that or nothing. And so I think we had to adapt. And I think that's what we do relatively well. We adapt. We pushed the puck a little bit later. So we actually went to our provider's arm. We went to the CAD people and we ask and get stuff. So I think right now we are actually at the point where we get things done. Cores are safe. IPs are becoming safe. You buy tools now. It's everybody has, I mean, whether it's Synopsys, whether it's Cadence, whether it's Mentor, I mean, Siemens, they all have now, safety checkbox done. And if they are not, we sue them. But that's as much as that's how it works. So, and that's the thing. And yes, there is still the problem of security that because sometimes security is orthogonal to it. The famous one is being that functional safety makes noise when there is a failure, and security is the opposite. You don't want to say that somebody is hacking you. Well, if there is a problem in the system is going to cry loud that there is a problem. So there are things that we have to do to actually mitigate both. But I think that's where the fun is actually at one point in time. I mean, I work with Bharat at the beginning, so.
Yeah, no, I have a slightly, different take on this. So just a show of hands, how many of us have ever been on a plane? Everybody? Okay. So do you know how people make sure that the microcontrollers that control the ailerons on a plane's wing, that control the shift or the lift of the plane, is not going to fail at 30,000 feet when you're doing a transatlantic flight? It's called 3 out of 5 majority voting. You put 5 microcontrollers down, and you're flying at 36,000 feet in the air. Even if there's an alpha particle event or a neutron event, you have the ability to take down a second microcontroller and do 2 out of 3 majority voting till you land the plane. So if it wasn't for something like functional safety, none of us we should all have nightmares before we would set foot on a plane. Okay? So that's the fundamental aspect. Yes, maybe there was a point in time where there's a checkbox, but that's no longer the case. And going back to Serge's example of an S-Class Mercedes with 200 computers, each with a gig of software stack, by golly, somebody better have written that code to follow some systematic capability compliance requirements. Otherwise, how are you even going to know whether or not, one of those 200 computers is going to do one thing, turn your car left, while the other one's turning your car right? Okay? So it's important. I mean, even just to go back to Serge's point about cybersecurity, one of the strongest defenses that most cars had
So I don't want to sound attacking Serge. Functional safety is not, it's not like a one function. I mean, probably you guys are aware there's a tier of things, correct? You know, from an IP provider all the way to the OEMs, each one of us does their own thing. So don't think just because you are a silicon company that whatever you're going to give to your customer, all the functional safety features that's going to be there to protect you when you're driving your car. It's not the case. Unfortunately for automotive, you have to be very frugal because really we don't charge our customers much, especially the silicon company. They don't charge much for safetiness. Pennies maybe over whatever they charge for product without safetiness. But think about it this way. The IP companies add features. Then the silicon guys provide more features. Then the tier ones provide more features. And this is not only for hardware, for software as well. I mean, I don't know exactly what the OEMs do for software, but the examples you talk about, the avionics and so on, I mean, these guys have N version programming and N can be 3, 4, whatever, so that you don't have systematic software bugs, correct? So, you know, it's complex, but it's doable. Now, today for automotive, for example, if you're only looking at the standard to make you safe, I think you are limiting yourself because the standard, probably you guys know how the standards, they bring experts from gazillion companies and they put them in a room, virtual room, and say, by the way, guys, write something that you all agree on. Well, what's the probability that that thing is going to be inclusive? Probably I would say 0. At the end, I mean, Carl Greb, who was one of the people who are driving the standard to ISO 226, he said that usually the standard is about 3,000 pages. Because again, these are notes that they need to agree on, and at the end it's about 300 pages. Where did the other pages go away? I mean, did they go away, vanish, they concise them? No, it's because these things they did not agree on. So companies like OEMs, and this is a discussion I have with an OEM, is that, do you trust us? He said, no. I mean, we trust our work. We don't trust you. We ask you to do something. If you do your work, the only thing we trust is that you did your work. But you're relying on you as a silicon company to give me a product and that I'm going to use this product as is and claim that my car or my vehicle is protected against anything? No. They have their own way of adding their own features. I mean, yes, they still want you to build the features that you promised to build, but at the end, they want to make sure that their product, when they deliver it, they can sign on it that, yes, I agree, this product is safe and people can use my product. So,
before we move on, just a logistic. I think we have the room for another 5 minutes, something like that. Okay. So, Bharat, thank you so much for coming. Absolutely. I know you have a flight to catch. I know. So, just wanted to say thanks again before we continue.
I have a really quick question.
Yeah.
How are you guys able to separate out the issue of security from the standards, from the safety standards? Because, I mean, as you've already brought up, hacking an automobile would allow you to obviate a lot of the safety standards that are built into it, right? So I don't really see how you can say security and safety actually have a separation, but at the same time, of course, the kinds of things you have to do to tackle either one of those conversations is complex, and to put them all in one 3,000-page document might be a little difficult to
Yeah, I'm going to take a stab at it.
Sorry, Serge, you were trying to say
Yeah,
something before?
yeah, I was going to respond to the last round of questions, I guess, and address this one. So first of all, the car hacking thing, everybody likes talking about it, but it's a non-issue. And the reason it's a non-issue is because the economics of attacking cars are terrible. There's nothing for anyone to gain. No, non-issue, okay? You have to think about attacks from the economics perspective.
Yeah.
People attack set-top boxes and bank cards because there's money. Adversaries attack defense systems to gain advantage. The cars are trivial to attack. There is no air gap anymore. Their infotainment system is connected to the internet. From there, through medieval protocols like CAN, it controls the rest of the car. It's for the people that we deal with in the defense community, this isn't even a challenge. But the thing is, the cars are extremely exposed, but they're not an issue because there's no money in attacking cars. There's no economic value proposition for the adversary. I would say that there is an interesting interplay here between safety and security that happens in all kinds of scenarios. So for example, you hit the brakes in your car. There are a bunch of messages that now go out on a network to different ECUs. One ECU then sends more messages asking each individual wheel controller about rotation speed. Those respond at some point in time by sending more messages on the network. Those messages arrive, the main ECU is trying to decide, so what does this mean? What do I do? How do I apply the brakes? Now, what if front left responds with 0? What if front right doesn't respond? What if none of them respond? What if the customer hits the brakes again and again and again before the first round of messages have been serviced? What I'm trying to say is there are so many corner cases that are not conceivable in mainstream operations that we are not covering today with simulation. And the best thing that the car people can think of is drive their car for 500 days in Antarctica and another 500 days in Sahara, which is never going to hit corner cases. So I don't object to the concept of safety. I'm just saying the solution here has to be technical first before we start layering administrative things on top of it. Because right now, there isn't a technology in place to even answer the simple scenario question that I just described about ABS.
I like how you summarized it. I think we all agree on the technical side, at least everybody on the panel.
Yeah,
here.
I mean, this thing I cannot disagree. But I was going to say, going back to your question, is that how do we combine security and safety? I don't think, as Serge was saying, it wasn't till like lately that people perceive that there will be attacks on somebody driving a car. And again, it's not to steal money from you, but it's to cause damage. Because think about it, let's say we're driving in Manhattan and some hacker penetrated into a CAN bus and start sending all messages left and right. Think of how much. Today we don't see that yet. But now we've been asked by at least the OEMs that you need to take care of security and safety. And I mean, again, I don't think that there's a bulletproof method to do that, but there are, like as I was explaining, there's an analysis on safety, there's an analysis on security. People are combining them now, saying, how do I make sure that all those attacks and all those failures are covered? And how do I know that there's no conflict between them, like what Alex was saying? I mean, we started doing that, but it's still early. And I'm sure, today there's no attacks on cars, but in the future there will be.
I would agree that these things have to come together. But right now they're considered by different groups of researchers. And
yeah, so I think from security and safety, the thing is, so I understand what Serge wanted to say, although his view of the ABS system is totally wrong, but that's fine. I've done my share of 15 years of ABS systems, so I know a little bit of that, and I tell you, it doesn't break like that. But for the security on the car, the problem is that the security in software for the car is only a problem that I think the car maker have been looking at for the last 5 years, to be honest. Because before that, like what Bharat was saying, is that they thought they were protected. And they were not. And in fact, a big car maker, a big German car maker was hacked because the mafia was infiltrating their development center, and they were able to put a Trojan into their system so that that mafia could actually steal their car. So of course, we're talking about high-end cars, and the only way they find out is because they were too greedy and sold too many cars of that model. And that's how they find it. But that was an attack on the can. And I agree with Serge, it's prehistorical network, medieval. But yeah, and there was no security on it, and nobody was doing any security. There are still some people that left breakpoint in the code. I mean, things that you will think are the first things to do is so I think security have been something that the car maker have looked at very recently compared to the rest of the world, and they are doing a lot of things now. But it's still the beginning, and today the way security of a safety problem becomes is that we do a failure analysis, and it becomes, oh yeah, if somebody does that with your software, then what is the failure that is going to ensure for the rest of the car, etc. So there are things to be done, but again.
So I would add, I like the fact that OEMs are focused on this now, and he's right. 5 years ago, nobody was concerned about it. But I think the emergence of autonomous driving, as we cede more control to machines, brings it more further to the foreground here. So I mean, I think this is definitely an area that where a lot of improvement, a lot of progress is needed. But you know, my thing is technical strategies is what's really lacking.
Thank you, Serge. I think we need to wrap it up. So thank you very much for coming. Please do check the website, see more information, join us. Thank you very much, guys.